First, good evening. Thank you for staying with me for the last hour of the conference. I really appreciate it. And we didn't need to lock the doors like we thought we would. My name is Ronen Friedman. I'm maintaining the Scrub code in Ceph for the last 5 years or so. This would be a short presentation of one specific Scrub-related table. A matrix that conveys how the various types of scrubs are affected or are limited by the configuration options that are available to the operator and by some environment conditions. Why I'm presenting it? Because in Tentacle, this matrix was clarified and fixed, and I hope it now better matches what an operator would expect of the scrubs that are running. Now, Scrub code in Squid and Tentacle went through a lot of changes. There are many important and visible improvements. Some of them are mentioned here, and we will not be talking about them. Okay, those presentations were rejected. So what we are talking about is one specific issue. So what is the table I'm talking about? The columns are the possible restrictions that can be placed mostly on the initiation of scrubs. Usually, we are assuming that the operator is using those configuration options to limit any adverse effect of scrubs on the I/O, the client I/O performance of the cluster. And usually, they are controlled by pool and cluster configuration options, with, as usual, pool options trump the general cluster ones. For example, one type of very simple restriction, the time of day and day of week, restrictions. You probably know the 4 parameters that control these. Simple. Okay, what are the rows of the table? On the row, we have the scrub types. Now, starting with Tentacle, these are named, the term we are using are urgency levels. And you can see the 6 urgency levels on the left as the rows. The urgency is a single attribute that encompasses what caused this specific scrub to be executed, to be scheduled. Its priority, and this is the list is in increasing priority, absolute increasing priority. We will always perform or try to perform operator requested, for example, scrub before we perform a repairing scrub. Okay, and a few other details. For example, its level, shallow or deep, usually, unless it's the first one, the periodic, and what we are talking about here is the specific set of restrictions that might be placed on this type of scrub. This is what we are talking about here. So let's start with 2 extreme cases of the table. On the one hand, we have the periodic scrub, the regular scrubs that are supposed to automatically be initiated either shallow or deep, each X days or weeks or whatever. Those are subject to the lowest priority and are subject to all restrictions that we will mention. On the other end, we will have the scrubs initiated by the operator. The 2 types, either regular scrubs or repair scrubs using the repair command. Those always go on. This is something that we started to change in Squid. In Tentacle, we completed the work. We can now say that almost always in a second why almost. Almost always, if you as an operator says scrub in a direct command, the scrub will go on, will be initiated. The one reason that I think the only one I can think of that it won't happen is if the PG is not in a state that allows scrub. For example, it's not clean. Okay, it's doing something else, it's doing some kind of repairing. On other cases, we will go on. But there are some things in between. But let's continue. So I'm going to fill the table on both sides, columns and rows, just to make things more interesting. Okay. Let's talk about a second simple thing. We have the extended sleep. Extended sleep is a configuration option that sets the sleep time. We'll see in a second what sleep time is. Sets the sleep time for those scrubs that were initiated during the allowed period, but took too long, and are now we are now reached a forbidden time. Okay, the idea is to penalize those scrubs to reduce their effect on client I/O. Okay. The parameter is OSD scrub extended sleep. If it's not set, what you'll have is the regular sleep time. And sleep, what is sleep? I'm not going to dwell too long on this slide, but just to remind you, the way scrub works is this. The basic state machine, how's it called? Forgot the name of the UML. The transition is after you perform a reservation of the replicas, we are looping over chunks, over all the objects in the PG, chunk by chunk. And for each chunk, we are asking the replicas to perform their own scrub, their own data collection, create their own scrub map. The primary, is doing the same, and then the results are compared. And you can see the yellow slipping rectangle there. We can introduce slip between each chunk. Okay? And setting this using higher slip level configuration means reducing the amount of operations the scrub will perform in specific time. Okay, that's easy. Let's add one more column, CPU load. CPU load restrictions are very similar to time of day. We restrict the scrubs if the CPU seems to be loaded. And the definition of loaded was always and is unless a CPU is not loaded if the load average is below a specific threshold or is below the daily average and is decreasing. This might be questionable, but this is how it was defined, and no good reason to change it. Okay. Let's add the missing levels. After repair, missing types, levels of scrubs, types of scrub. After repair, scrubs are initiated in one specific scenario. This is when we had a scrub that detected the errors and initiated our recovery. And when the recovery process completes, a second deep scrub is triggered just to verify that things were okay. This type of scrub has higher priority than periodic, and it ignores extended sleep and load. It will run even if the CPU is loaded. Basic idea is that you just finished your repair, you really want to know that it works, so we don't care for the load. A second, a more important, more meaningful restriction is the idea of replica reservation. If you remember from the transition slide I saw earlier, usually a scrub starts by the primary OSD requesting the replicas for their resources. Okay? And each replica counts the number of scrubs it participates as a replica. Each OSD counts the number of scrubs it participates in as a replica. And once we reach OSD max scrubs, such requests will be queued. Now, this is a major change that happened already in Squid. Once we were simply rejecting such requests, and there will be sometimes hours of rejections and racing to get, usually in EC clusters where you have many replicas for each PG. It will be hard to get for the primary. For the primary, it will be hard to achieve grants from all the replicas. This is no longer so. We are now queuing it like other systems in Ceph. Now, this is the major point of control for the operator for the number of concurrent scrubs that are performed in its cluster. For a long time, this restriction applied to all scrubs, starting with Squid and more so with Tentacle. It does not apply to high priority scrubs, and you can see it here in the table. Okay? Now, the next column is the max concurrency, which is the same idea, but when looking from the primary OSD view. An OSD, as a primary, would not initiate more than the same parameter, OSD max concurrency, would not initiate more than this number of scrubs concurrently. And a personal request, because I have to debug, I have to debug the logs when there is a problem. Please do not set this parameter to what was the default before Reef, which was 1. Because 1 means that if there is even one OSD that is problematic, many PGs would not be scrubbing forever until that OSD is reboot. So the default now is 3. But if you're not a busy cluster, you might want to set it much higher. Okay. The fourth from the beginning, the fourth type of scrub is repairing scrub. This is something that is automatically initiated if a shallow scrub finishes with errors and the right combination of parameters allow an automatic deep scrub with repair to be initiated. Okay, the details are here. I don't want to spend time on that. And repairing scrub ignore most of the constraints that we mentioned, if you see that in the table. Note interesting thing is that repairing scrub do not need reservation, but they do respect the local concurrency. The OSD won't start too many scrubs, even if they are repairing scrubs, but we'll accept being part of such scrubs from other OSDs. Okay. And the last scrub type we haven't mentioned, this is a mass scrub. Mass scrubs are shallow scrubs that are it's not an important distinction, but mass scrubs are almost periodic scrubs, but they are initiated when we don't know when the last scrub was performed, which usually happens when you have a new PG, or just created a pool, or just made some change that created new PGs, and we don't have a previous last scrub stamp. In this case, and if the configuration is set, we will immediately try to scrub. And mass scrub are low priority, relative low priority. They respect almost all the restrictions that we mentioned. Okay, let's continue with the columns, restrictions. Each OSD initiates the scrubs for itself. For itself, it means those PGs for which it is the primary. And the way it's done internally is that there is a tick, a process that runs every second in the OSD, and it does a lot of things, but the most important thing it does, from my view, it rolls a dice, and if the dice roll is high enough, we will perform the scrub. Now, this one comment to the operators, and this was a request by some, this was a question, not a request, by some operators. Suppose I want to perform the whole scheduling by myself. I don't want any periodic scrubs to run. You can do that. You can set the times, the periods for the scrubs to be very long. That's one way. And on the other hand, you can set the backoff ratio such that the dice roll would never get a good enough number. Okay? Another issue is scrubbing while recovering. Now, recovering here doesn't mean that the PG is recovering. If a PG is doing some backfilling, it won't scrub. You can't scrub in such a condition. But the idea is that the primary OSD is performing a recovery, and you might decide that you don't want to burden that OSD with some other work. You want to finish that work as fast as possible, and there is a parameter for that. If OSD scrub during recovery is true, this doesn't apply to your cluster. But if it's not, as you can see in the table, only operator-initiated scrubs are allowed to go on. Now, there was, until Tentacle, there was another, you might ask yourself about another configuration parameter that says that only, how was it called? Only explicitly requested scrubs will go on. The logic somehow lost its meaning and was reversed during the years, and it was removed in Tentacle. This is the correct table, and this is a change from what you used to know. Okay. And I think that's the last one. It's the no scrub flags. You can set no scrub flags, the two flags, no deep scrub and no scrubs, both on pool level and on cluster level. And they are usually honored and respected by most types of scrubs, apart from the three that you see mentioned. Operator requested, initiated scrubs always go on, and after repair, will go on. The idea is that you just initiated the repair. Or basically, you initiated the scrub that caused the repair. So you really do want to have the check after that. So this is the table. And there are some changes here. If you look at description of some of the configuration items that I mentioned in previous releases, the descriptions do not match this in 100%. So there are minor changes. I think they are clarifying. I think they are better answering what operators requested of us. And in some cases, they fixed misalignment between different documentations and the code. OK. So this is the first part of the code, and I do have a few minutes to say one more thing. Now, if you have memorized this, you should have my presentation from the last Cephalocon. You might have noticed that something that I mentioned there is missing from here, and that's the overdue functionality. Overdue regarding Scrub was always a bit overloaded. There are two levels of being overdue for Scrub. One was the health warn level. There is a parameter, we see it in a minute. If Scrub is not performed on specific PG in the time that is set by that parameter, the cluster is not healthy. OK, that's simple. But apart from that, we had one more thing. We had an internal overdue but not health risk, always. And for a long time, this status conveyed some higher priority in some way, which wasn't very clear from the documentation. You had to read the code to understand what the documentation meant and what was correct and what's not. For example, it was allowed to run when the CPU load was high, but it wasn't clear it was allowed to run in rush hour, in the forbidden hours. Now, this is removed. It served no good purpose. It was removed. And now the only thing that's left is the health warn. And being overdue does not grant priority by itself. OK? Basically, there were people that worked on convincing me that if the cluster does not have the resources to perform scrubs for the whole cluster in time, it doesn't matter if you give higher priority to one specific PG that reached overdue. You have a resource problem regarding scrub, so it doesn't serve a purpose. So how does being overdue look, and what was changed? So, OK, I have a few minutes. This is how shallow scrubs were scrubbed before the changes in Tentacle. I think you all know, probably if you're operating clusters, you know the configuration parameters mentioned here. The way to schedule shallow scrubs was to set a mean interval by either of two configuration parameters, and another randomization parameter that prevented the idea was to prevent a thundering herd problem of all the PGs starting to scrub at the same time. There was another feature that shallow scrubs might have been upgraded randomly to deep scrubs. This was removed. It was surprising and undesired, according to what we learned from the operators, and we improved. We'll see in a second what we did there. And then there was a setting that said the max interval, and we had from max interval to the health issue, that time, which is another parameter, we had a vague area of overdue, but nothing changes. Internally overdue, but it's meaningless. And then health warning. What we changed? Easy. We moved the internal period that meant nothing apart from seeing something in the logs. Okay? That's for shallow scrubs. For deep scrubs, this is not the presentation to discuss this, but deep scrub scheduling is totally different from what it was before Tentacle. Before that, we had some desired interval and a randomization factor, like I said, that caused regular scrubs to become deep scrubs by some random amount. What we did now is, I hope, clearer. It's easier to explain. The operator sets the desired interval, and the deep scrubs are randomly distributed around this with a standard deviation value that is set by parameter. Okay? And we are clamping the times to 2 standard deviations, whatever the user said. Or basically, the operator has full control over the scheduling of deep scrubs. Now, by the way, this is part of a change that was made, a bigger change in Tentacle, that is, again, not what we're talking about, of changing the way the queue is implemented and presented, the queue of PGs to scrub. Now, the queue does not hold PGs, but rather it holds targets, when a target is the PG and the level. Or, in other words, what the OSD now schedules are not the PGs, but the shallow scrubs for each PG and the deep scrubs for each PG, separately. We removed the interchanges and the interrelations between running a deep scrub and a shallow scrub. Apart, of course, from the fact that if you run a deep scrub, it counts as running a shallow. But apart from that, we removed the influences between those two. This, for example, required us to change the way we store scrub results and to separate the database that stores scrub results from one scrub to another, to separate it internally to 2 databases. Otherwise, we had a problem. So, like before, we had the cluster health warning overdue and the internal overdue, which carried no effect. And as we did before, we don't anymore have this internal overdue. Either we scrub in time, or in one point, which is set by a parameter, a mon parameter, by the way, in this, for the health warning, we have a health issue. Okay, and surprisingly, I finished all I wanted to say. Any questions? Yes.
Yeah, I wanted to ask you about load average. Specifically, you said there's no good reason to get rid of it. I wanted to counter asking, is there a good reason to keep it? Because the intent of that is to try and throttle scrubbing if the system's overloaded. But that now is kind of governed by and CPU load may or may not have anything to do with the actual storage, underlying storage. So I wanted to ask if you considered getting rid of it. We've seen issues with hyperconverged clusters where high CPU load that has nothing to do with the storage cause bad scrubbing behavior.
Okay, let me repeat the question. The question is, why don't I get rid of the CPU load restriction? It's a good question. The answer is basically that there is no good reason to get rid of it, and there might be some operator that rely on it. Why it's very easy to get rid of, to get over that simply by setting the threshold level very high, and that just removes this the settings, and it doesn't cost much. Internally, we already have we're already querying the CPU load average for other reasons. We display it in logs or whatever. So I don't care to live. I don't mind leaving it inside. If it's a good question, does anybody here make use of this? The effective use of the load average? Sorry?
So we have set it to like half of the machine of the load, total load of the machine that it's capable of. So if you have, for example, for 34 cores, we set the max load to 12. So
Okay.
just to have some like limit that is there.
Okay. It doesn't limit the amount of CPU that is used by scrub. You just limit once you reach it. I won't initiate periodic scrubs. Okay, so, here's the reason why we are keeping this.
Have you considered raising the default?
That might be a good idea. I won't say it won't be. We are playing.
And are you concerned about Crimson? Because with Crimson, there's going to be much higher CPU load with the way it busy waits, at least my understanding. Are you concerned about how Crimson might interact?
Well, before I forget, another point that you mentioned, the slips are not, I think I wrote it in the slide, slips are ignored, the slip time is ignored if you're using the mClock scheduler. Now, for the question, I don't know. I don't think the CPU load in Crimson is a bit of a problem because you don't see it. It's always 100% because of the way the CPU works. But I don't know yet. I don't think this. It's never the problem of the CPU when doing scrub. You're reading data. You're performing I/O. So it's almost never.
We will try to introduce also a way to not busy pool your CPU if you're not into performance. So that will be available for scrub. But I guess scrub, once we introduce mClock and more sophisticated scheduler, we'll know how to put in scrub in between I/O requests and client requests. So that's why we are not having it background scrub.
I have seconds left, so just a request for me. I'm almost out of things to do that are user originated. I have my list of things to do which are internal, but I'm almost out of requests for changes for scrub. And so please email me for things that bother you if you have problems.
I have one question, maybe not directed to the scrub procedure, but we don't have scrub duration
can get that duration from that PG dump comment, I believe, was output.
It's there, yeah.
But we don't have it as a metric, and it would be quite beneficial because we have problems with deep scrub performance, and we want to try some things, to tune some things, but we don't know if things go better or worse because we don't have easy way to compare it. And it was really
Yeah, well, half of the answer is that REIT is working to include some scrub-related performance counters in the next Squid point release. And if there is specific data set where it's missing, write to me. So I'll try to add that. Any other question? Thank you.